Greetings, greetings. I'm back again for part four. All right, this is part four in regards to us as the Central Torah tribes understanding and interpreting cosmogony. All right, because you came from the stars and you should return to the stars. All right, in your truest form. All right, in your truest form. And on that topic, let's discuss star, because we know a star's life begins one second. As it said, a star life begins with the gravitational collapse of a gaseous nebula of material largely comprising of hydrogen, helium, and traces of heavier elements. Its total mass mainly determines its evolution and eventual fate. A star shines for most of its active life due to thermonuclear fusion of hydrogen into helium in its core. This process releases energy, time to get comfortable, that traverses the star's interior and radiates into outer space. All right, universe. At the end of a star's lifetime, its core becomes a stellar remnant, i.e., a white dwarf, a neutron star, or if it's sufficiently massive, a black hole. Okay, so when we're talking about gravitational collapse of a nebula, which is eventually results into what we call a star, i.e., our present star, uh, it's a result of, as they said, a white dwarf, a neutron star, or a massive black hole, which we know the end of the fate of this universe will be the same fate as the collapse as we've seen in the Helix Nebula. All right. The same fate that we've seen in the Helix Nebula is the same fate our star is going to suffer. We know that the closest nebula, which was once a star, which once with birth our star, that's what I would assume, because if a star begins with the gravitational collapse of a nebula, we know a nebula is what we call a cloud or what they call a molecular cloud, you know what I'm saying, which composed of what we just seen here based off of the description. And it says that at the end of that star's lifetime, the core becomes stellar remnant, a white dwarf or a neutron star, and sufficiently massive as a black hole. We know that nebulas have black holes. Nebulas have black holes. We must understand that. All right. So we're talking about a gravitational collapse in the nebula. You know what I'm saying? We know that a gravitational collapse in a nebula, we know a nebula is based off gaseous space that existed under what they call, what they described it as interstellar medium. And interstellar medium was occupied before that space was there to, before that space was there, was what they call ether, a luminous spheroid ether. Okay, luminous spheroid ether. Let's go through here. Gravity, back to gravity. Not gravity, what was it? Big Bang. As we can see in the Big Bang, let's see, this is called a helix. You see it when it forms like a spiral. That's called the curvature of space and time. Space time, a curvature in space and time, which is subject to the gravitational pull, which causes a quantum fluctuation. All right, which is a vacuum. All right, a vacuum with light travels. Because we know light is energy. We know energy is electromagnetism. All right, as you can see by the example they have here, dark energy. All right, dark energy is called quintessa. All right, dark energy is called quintessa. And we know quintessa is ether. This is, as they said, is what the planets swim in. You see, as we can see on here, the planets are swimming, and they're subject to that of what they call a vacuum. As a result of the gravitational pull that resulted from a nebula, which gave birth to the star by way of the gravitational pull collapsing. We see the gravitational pull is causing all the planets to go or be subject to that suction, that vacuum. All right, quantum fluctuation. All right, let's do this even more. Big Bang. Let's look at space and time. I'm not a professional. I just try to make sense of what's been given to me. If I'm wrong, you have the perfect opportunity to correct me, no matter what school of thought you're in. All right? Space and time. Space and time. Back to the Big Bang or cosmogony. All right, how the universe came to be. We know that our star life and we know that the star's life is subject to, uh, as it said, uh, the gravitation, the collapsed gravitational pull of that force of that nebula. And we know the closest nebula that's to Earth is what they call the Helix Nebula. All right. You have a bunch of nebulas. Orion's got theirs. Orion's constellations. Buddha's constellation got theirs. Buddha's void is another example of a black hole, void of space. All right, void of space. All right. So you see the example here as shown in the Big Bang effect, cosmogony, how our universe came to be about, which was result about here. This is the result. We see that our universe as exists here is a result of what we call expansion of the universe. Expansion of the universe. But we know that expansion of the universe is within the domain of what we call dark energy. Because it swims within dark energy, i.e., the ether, which is a fluid. All right? A fluid that lives within, that allows that nothing to exist, that nothingness to exist, that void. All right? It allows that nothingness or that void to exist. And it says here the timeline of the expansion of the universe, where space, including hypothetical non-observable portions of the universe, is represented at each time by a circular section. On the left, the dramatic expansion occurs in an inventory epoch, and at the center, the expansion accelerates. Artists neither time or size are to scale. But as we can see, it's like a helix, dark energy. See the point? That's a helix, spiral. That's called curvature. Let's go to space-time. As you can see, pretty much the same example. You see Earth, terrestrial planetary sphere, is being subject to a vacuum where matter cannot enter. So it must be at what they call 0 point energy, because general relativity theory is subject to special theory of relativity. Special theory of relativity. Once again, general theory of relativity is subject to special theory of relativity, because in order for the gravitational pull to collapse, it must enter what they call a 0 point energy, i.e., energy matter equivalence, which is subject to the Albert Einstein theory of E equals mc squared, which energy is constant to the speed of light, i.e., interstellar, antimatter. You go into that understanding, the study of ether. How we know that? Let's look. In physics, space-time is a mathematical mode that fuses the 3 dimensions of space and the 1 dimension of time into a single 4th-dimensional continuum, i.e., vacuum. Let's read this. Continuum theories or model explains various of involving gradual quantitative transition without abrupt changes or discontinuity. In contrast, categorical theories or models explain variations using qualitatively different states. In physics, for example, the space-time continuum model describes space and time as part of the same continuum rather than a separate entity. A spectrum in physics, such as the electromagnetic spectrum, is often termed as either continuous with energy at all wavelengths or discrete energy at other certain wavelengths. This is what you call a transmission medium. An interstellar medium is a transmission medium. All right, the ability for signals, waves to travel through. All right, let's go back here. Space time. Until the 20th century, the assumption had been that the 3 dimensional geometry of the universe is description in terms of location, shape, distance, and direction. Was distinct from time the measurement of when the event occurred within the universe, i.e., singularity, gravitational singularity. Where was it at? Gravity singularity, space-time singularity, or simply singularity is a condition in which gravity is predicted to be so intense that space-time itself will break down catastrophically. As such, a singularity is by definition no longer part of a regular space-time and cannot be determined by where or when. Gravitational singularity exists at a junction between general relativity and quantum mechanics. Therefore, the properties of the singularity cannot be described without an established theory of quantum gravity. That goes back into what we talked about when we folks open up, cosmogony. In astronomy, cosmology refers to the study of the origin of particular astrophysical objects or systems, and is most commonly used in reference to the origin of our universe, the solar system, or the Earth-Moon system. The prevalent cosmological model of the early development of the universe is the Big Bang theory from a singularity, i.e., gravitational singularity, which we just read. Okay, we just read it. Let's go back to where we was. space-time. In 1908, Hermann Minkowski presented a geometric interpretation of special relativity, not general relativity, but special relativity, that fused time and the three spatial dimensions of space into a singular fourth dimensional continuum known as Minkowski space. This interpretation proved vital to the general theory of relativity, wherein space-time is curved by mass and energy, i.e., E equals mc squared. All right, let me see where this takes me. Let me go back here. Because it's said right here, special relativity. You got general relativity and special relativity theory, both presented by Albert Einstein. Zero-point energy. Everybody pull that up. This is cosmogony. All right. Zero-point energy. Zero-point energy is the lowest possible energy that quantum mechanics system may have, i.e., quantum mechanics. We were talking about that when we were talking about what we were talking about. What were we talking about? I think it was. Let's talk about a second ago. I got a short memory span. Forgive me. It'll come back to me, but let's get back to zero-point energy. All right, zero-point energy. I think it was gravitational singularity. All right, gravitational singularity. That's what it's. Gravitational singularity, space-time singularity, or simple singularity is a condition in which gravity is predicted to be so intense that space-time itself will break down catastrophically as a result of that vacuum. All right, as a result, there you go, quantum mechanics. All right, as a result of that vacuum. All right, space-time deals with moving from three-dimensional to fourth dimensional as a result of that vacuum. Because not even light can escape dark energy. Not even light itself can escape dark energy. It says the gravitational singularity, space-time singularity, or simply singularity, is a condition in which gravity is predicted to be so intense that space-time itself will break down catastrophically. We know that singularity deals with the creation of our universe. We know the universe and our sun that this was not a universe was a result of the as I said, the gravitational collapse of what they call a nebula, i.e., a planetary nebula. And a planetary nebula is what we call a fog, a cloudy fog of a luminous spheres ether. Okay, luminous spheres ether, intense compact energy. All right, compact energy exploding. It says gravitational singularity extent at a junction between general relativity and quantum mechanics. Let's go back to 0 point energy. Zero-point energy is the lowest possible energy that quantum mechanical systems may have. Unlike the classical mechanics, quantum systems constantly fluctuate, i.e., quantum fluctuation. Let's look at that real quick. What is quantum fluctuation? In quantum physics, quantum fluctuation, known as vacuum state fluctuation or vacuum fluctuation, is a temporary random change in the amount of energy in point in space. Energy equals mc squared. Energy equals mc squared. Energy, matter, constant, speed of light, i.e., antimatter. Remove matter from space and time through what we call vacuum. The only thing that exists now is what we call antimatter, subatomic particles. All right, understand this. 0 point energy. Let's go back to that. Okay, let's see. I know I've seen that word. Okay, I know I wasn't tripping. All right. 0 point energy is the lowest possible energy that quantum mechanics systems may have. All right. We're talking about gravitation, what it says, gravitational singularity. Gravitation singularity deals with the point of the expansion of the universe. The point of the expansion of the universe, which they call the Big Bang, i.e., cosmology or cosmogony, whatever the word they use. All right, it says, therefore, at absolute zero, atoms and molecules retain some vibrational motion, i.e., vibrational motion. Apart from atoms and molecules, the empty space of the vacuum also has these properties. According to the quantum field theory, the universe can be thought of not as isolated particles, but continuous, you hear that? Continuous fluctuating fields, matter fields, whose quanta or fermions, i.e., leptons and quarks, and force fields, whose quanta or bosons, photons and gluons. All these fields have 0 point energy. These fluctuating 0 point fields lead to a kind of reintroduction of an ether in physics. Did you hear that? Of an ether in physics. The notion of 0 point energy is almost important for cosmology, and physics currently lacks a full theoretical model for understanding 0 point energy. 0 point energy. All right. Now, what is it? What's it with another term? What's it called? What was it called? 0 point energy. Do I have it here? Okay, let's move on. So we know that in 0 point energy, 0 point energy is the lowest possible energy that a quantum mechanics system may have. And it says that therefore, even at absolute zero, atoms and molecules retain some vibration motion. Apart from atoms and molecules, the empty space of the vacuum also have properties. So whether it's a vacuum, in quantum field theory, quantum vacuum state or quantum vacuum or vacuum state is a quantum state with the lowest possible energy. Generally, it contains no physical particles. The term 0 point field is sometimes used as synonymous for the vacuum state of a quantum field, which is completely indivisible. Excuse me. All right, let's go back to the video.
Most people have no clue that in 2023, the best way to make money on Amazon is not with physical products. It's Amazon's other company.
Quest is to locate a star that transitions from unwavering stability to complete disappearance, a phenomenon that has not yet been documented. Such a discovery has the potential to unveil new realms of physics. Perhaps you're wondering, is it truly possible for a star to simply vanish without warning? The answer is yes. For instance, a star was under astronomers' monitoring for a significant period, spanning 2 decades until 2019. Their fascination with this star was partly due to its dazzling crystal blue radiance. Then, suddenly, it ceased to exist. Andrew Allen, a doctoral student specializing in astrophysics at Trinity College Dublin, meticulously examined and re-examined the data. The star's immense distance made it impossible for telescopes to observe it directly. Therefore, astronomers sought the distinct signatures of these luminous blue stars on the light emanating from their parent galaxy. Astonishingly, these telltale traces had disappeared. During that period, the leading theory suggested that the star had undergone a supernova explosion, leading to its transformation into a black hole. However, there were no distinctive indications of a supernova occurrence or the expected aftermath. Neither was there any observable black hole. Considering the time gap between observations, it was extremely implausible that such a dramatic event had escaped notice. As emphasized by Leir Arkavi, an astronomer affiliated with Tel Aviv University, if indeed the star transitioned into a black hole devoid of any supernova activity, it represents a scenario of vanishing without the customary spectacle, a phenomenon astronomers have been seeking answers to for a considerable duration. With this, Leir suggests that some stars may transition directly from their dying phase to becoming black holes without the anticipated spectacular supernova explosion. There have been hints of such occurrence.
You hear that? Without this supernova explosion, they become black holes. All right? Without a supernova explosion, i.e., a Big Bang, they become black hole. We know black hole is subject to space-time as a result of the gravitational pull of that large what they call black hole, which is subject to a vacuum, and light itself cannot not even escape it. If light can't escape it, matter cannot escape it because all matter must fall to what they call 0 point energy. All right, 0 point energy as a result of that vacuum. Vacuum only light can travel through. We know light, which is based off a transmission medium, i.e., interstellar medium. We know interstellar medium is signals waves from one point to another, i.e., F waves.
Dating back to 2009, when a star that had drawn the attention of numerous telescopes appeared to be approaching a climax. The star later transformed suddenly into a black hole before scientists could fully comprehend the transformation. While definitive proof remains elusive, this event left astronomers perplexed. Equally significant is the collaborative effort of multiple research teams, including those previously mentioned, to compile comprehensive catalogs of stars and their characteristics. These catalogs enable astronomers to view stars online alongside others and compare data extensively. The results have been both promising and astonishing. As one researcher noted, they have discovered a multitude of short-lived transients that appear in one image and then vanish, constituting most of our findings thus far. However, there remain other phenomena that defy immediate classification. They examined some of these brief transients and ruled out possibilities
That's
like
called a
then
helix.
dwarf flares or nova. Expanding on this,
Spiral.
a common notion among some astronomers is that the disappearance of these stars may be attributed to the way light traverses the vast expanse of the universe. Visualize a light source in your room and imagine walking away from it until it vanishes. Now, extend that distance across galaxies. It raises the question of how we can perceive anything at all. The answer is that the myriad light rays emitted by these stars take an extraordinarily long time to reach us. Even when they finally arrive, they mingle with our sun's rays, enhancing their visibility in our night sky. The light we perceive is, in fact, many, many years old. In the case of our sun, its constant emission of light keeps it visible every day. However, even though it's relatively close, the sun's rays still require approximately 8 minutes to reach Earth. When applied to stars located light years away, the age of the light we observe becomes evident. Why is this relevant? It's simple. The apparent instantaneous blinking out of stars might result from the staggering age of the light we perceive. While it seems immediate to us, the star could have ceased to exist long ago, and we are only
I was not able to chew. That's just how loose they were.
just realizing its absence. This also ties into the concept of stars undergoing prolonged periods of brightness followed by fading to the point where we can no longer detect them. It's an intricate notion, and though unproven, these inquiries must be posed to uncover the truth behind these phenomena. Of course, some are inclined to explore the most extreme possibilities within these theories. For astronomers, the most
Ezekiel's well, the chariot, is right there. Meet him in that molecular cloud, i.e., that black hole, i.e., that vacuum. All right, moving from 3-dimensional to 4th dimension. You're going to talk. That talks about a Dyson sphere, a white door, a white door. The ability of a nebula exploding gives the ability to become a Dyson sphere. All right. Anybody ever heard of that theory? Please check that out. The ability of a nebula exploding gives the capability to become a Dyson sphere as a result of its masses now, and its masses determines the gravitational pull that it has on other objects. All right, which is discussed in a second.
most notable theory concerning vanishing stars involves extraterrestrial beings. You might wonder, how could extraterrestrial beings make stars vanish? The answer lies not in causing stars to disappear, but in the possibility that they might use these celestial giants for their objectives. Are you familiar with the concept of a Dyson sphere? Currently relegated to the realm of science fiction, it envisions advanced alien civilizations, or exceedingly rare circumstances on Earth, constructing a specialized megastructure around a star. This megastructure serves as a means to capture and exploit the star's energy and power on an enormous scale, effectively transforming the lead into a colossal energy source, or even a formidable weapon. This is similar to the depiction in Star Wars, The Force Awakens, where the Starkiller base harnessed a star's power to obliterate several planets of the Republic. However, the possibility of such an explanation faces substantial hurdles. First, the existence of extraterrestrial life remains unconfirmed. Moreover, realizing a fully functional Dyson sphere, even around a relatively small star, would require extensive time and extraordinary technological sophistication. When you consider applying this across more than 700 trillion stars as a monumental galactic endeavor, its likelihood is highly questionable. Nevertheless, this concept still garners believers. So where does this
Okay.
leave us? The answer is
okay. So they spoke about a Dyson sphere. All right, they spoke about a Dyson sphere, extraterrestrial intervention. All right, extraterrestrial intervention. All right, we know that the extraterrestrial has the ability to travel interdimensionally from one dimension to the next dimension. All right, at the speed of light. You know, to travel at the speed of light involves antimatter, or knowledge of antimatter, or the use of antimatter. All right, so it's very important we understand that because they know more than they're telling us. Why do I say that? Let's review that. Dyson sphere. I talked about this in a past lesson a while ago. We're going to read about it before we watch the video. Dyson sphere is a hypothetical megastructure that encompasses a star and captures a large percentage of solar power outlet. You hear that? That's the reason why they're allowing you to get solar panels. All right? Free of charge. They're allowing you to install solar panels to install them on your houses or whatever facility that you got going, your houses, your business, etc., as well as the satellites that they already have out and, like they said, outside of this terrestrial sphere. All right, we just had the video I showed you the other day dealing with SpaceX Skylink. All right, which is they are supposed to be a bunch of satellites. All right, what's the purpose and intent of these satellites? We're reading it. A Dyson is a hypothetical megastructure that encompasses a star and captures a large percentage of its solar power output. We're talking about CERN. All right, everybody know about CERN, messing with what they call the power of the sun. All right, you see in the movie Spider-Man. The concept is thought experiment that attempts to imagine i.e. imagery, mental imagery, all right? Visual imagery and mental imagery, all right? Very, 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 very important because we know that a transmission medium through an interstellar medium is through what we call telecommunications, all right? To communicate to you, all right? It's just the concept of thought experiment that attempts to imagine how a spacefaring civilization would meet its energy requirement once those requirements exceed what can be generated from the home planet resource alone, i.e. planet Earth. Because of the only tiny fraction of star energy emissions reaches the surface of an orbitable planet, building structures encircling a star would enable the civilization to harvest far more energy. All right. The first modern imagining of such a structure was by Olaf Stephenson and his science fiction novel Star Maker. The concept was later explored by physicist Freeman Dyson in his 1916 paper search for artificial stellar sources of infrared radiation. All right. Dyson speculated that such structures would be the logical consequence of escalating energy needs of a technological civilization and will be necessary for its long-term survival. A signature of such spheres detected astronomical search could be an indicator of extraterrestrial life. We just heard it on the video, now you're reading it. Now let's check out this Star Maker. Let's go to the plot. Star Maker is a science fiction novel by British writer Olaf Stephenson, published in 1937. The book describes a history of life and the universe, i.e. cosmogony. Dwarfing in scale of Stephenson's previous book, Last and First Men, 1930, a history of the human species over 2 billion years. Starmaker tackles the philosophical theme such as the essence of life, of birth, decay, and death, and the relationship between creation and creator. A prevailing theme is that of progressive unity within and between different civilizations. All right, let's go to the plot. A human narrator from England, very important. A human narrator from England is transported out of his body via unexplained means. Once again, a human narrator from England is transported out of his body via unexplained means. So he's traveling through what we call space and time. How can one do that? How can we do that? Right? Because it ain't based off what he's actually seeing. Traveling space and time is a mental process. All right? Psychological process. All right? A psychological process to transfer, to travel into, transfer from this dimension or this realm to a spiritual realm, i.e., another dimension, through other means, absent of the body, i.e., absent of matter, moving through space and time. So how is this done? Or how do we do this? All right. It says, a human narrator from England is transported out of his body via unexplained means. He realized he is able to explore space and other planets. After exploring a civilization on another planet in our galaxy at a level of development similar to our own that existed millions of years ago, thousands of light years from Earth, i.e., the other Earth. In some detail, his mind merges with that of one of its inhabitants. You hear that? In some detail, his mind merges with that of one of its inhabitants. And as they travel together, they are joined by still more minds or group minds. Y'all better pay attention. This snowballing process is paralleled by the expansion of the book scale, describing more and more planets in less and less detail, i.e., luminous spheres ether. Luminous spheres ether. All right? The disembodied traveler, you hear that? The disembodied traveler encounters many ideas that are interesting from both science, fictional, and philosophical points of view. These include many imaginative descriptions of species, civilizations, and methods of warfare, descriptive of multiverse, and the idea that the stars and pregalactic nebula, i.e., planetary nebula, are intelligent beings operating on a vast time scale. A key idea is the formation of collective mind for many telepathically, i.e., telecommunication linked individuals on the level of planets, galaxies, and eventually the cosmos itself, i.e., cosmogony. That's what you should be studying. All right? This is what you should know at this time. But you travel interdimensionally, do not with your physical body because it can't go there. Only your mind can go there. Y'all better pay attention. We already made that. We call it engrams or what we call autobiological memory. Autobiological memory. Well, what do I mean by that? Let's show you. Y'all better listen to me. Look at what y'all looking at. Look at what y'all looking at. Still a body, but dense. Still a body, but dense. An etheric body, less dense, not made of matter. All right? Not made of matter. All right? This is 3-dimensional. You move to 4th-dimensional. You're bending space and time by 0-point energy. This is your etheric body. All right? This is your etheric body. How do we maintain or upload to our etheric body? Let's see how. You ever daydream? Everybody daydreams, right? About what they want or what they remember or present situation. Everybody daydreams. But in their daydreaming, you have control over it. You know what I'm saying? Versus dreaming unconsciously. You know what I'm saying? Like you're sleeping. You have control over your thoughts and daydreaming versus your thoughts while you're sleeping. All right. This is an out of body experience, or sometimes will be. It's a phenomenon in which a person perceives the world from a location outside their physical body. In order to do this, everybody must close their eyes. Close your eyes. So you're no longer viewing it from the location that they want you to view the perspective. You're viewing it outside of space and time because you're viewing it with your mind, not your brain or your physical body. This is a visualization of your mind, a mental transfer to what they call an out of body experience that's only occupying space and time through what you perceive what space and time is. All right. And your perception of space and time or how you perceive it is based off what you see with your eyes, not with your mind. Because your mind ain't attached to your body. Your eyes are attached to your body, not your mind. So if you look with things to your eyes, then the mind is no longer being the spectator. The physical body is being the spectator. Everybody open their eyes. And that's subject to change, what you see. It's limited. Light is finite. It's only a transmission medium for signals and waves to travel through by way of vacuum, where the body can't go. So we're moving to space and time with our mind to have an out of body experience they call OB. All right? In which a person perceives the world from a location outside their physical body. And OBE is a form of autoscopy, literally seeing self. Although this term is more commonly used to refer to the pathological condition of seeing a second self. All right? What is autoscopy? Autoscopy is experience in which the individual perceives the surrounding environment from a different perspective from a position outside of their own body. Autoscopy comes from the Greek word self and scopus, meaning watcher. Autoscopy has been of interest to humankind from time immemorial. Did y'all hear that? From time immemorial. I don't believe they use that. It's abundant in this folklore, mythology, and spiritual narratives of most ancient and modern societies. Cases of autoscopy are commonly encountered in modern psychiatric practice. According to the neurological research, autoscopic experience are hallucinations. Their root cause is unclear. Autoscopic experience can include non-mirroring real-time images, and the experience may be able to move. All right? Autoscopy. We call it engram, i.e., hallucinations. So you're not crazy. We are not crazy, y'all. All right. And it said from time immemorial. All right. Don't look at that term loosely. What is time immemorial based off law? Okay? Y'all don't hear me. Time immemorial is a phrase meaning time extended beyond the reach of memory, record, or tradition, and definitely ancient. Ancient beyond memory or record. The phrase is used in legally significant context as well as in common parlance. You hear that? In law, time immemorial denotes a period of time beyond which legal memory cannot go. All right? And time out of mind. Most frequently, the phrase time immemorial appears in legal cases and legal terms of art and judicial discussions of common law development in the United States and the property rights of Native Americans. All right? We see time immemorial based off this plane, and we see time immemorial in reference to the what we call the plane dealing with what we were just talking about. What was that we were just talking about? I know it slipped my mind. What were we talking about? What was I can't believe it slipped my mind that quick. Bear with me, y'all. Let me just read this right quick. Time immemorial is strictly described the time required for a custom to mature into a common law. All right, into a common law. Medieval historian Richard Barber describes this as the watershed between a primarily oral culture and a world where writing was paramount. Common law is a body of law identified by judges and judicial proceedings rather than created by the legislator. The judges determined the common law by pinpointing legal principles consistent, reiterating in previous legal cases over a long period of time. In English law, time immemorial ends and legal memory begins at 1189, the end of the reign of King Henry II. King Henry II, the son of Godfrey, the fifth Count of Anjou, son of Folk, ruler of Jerusalem. All right, ruler of Jerusalem. All right, let me go back to where I was, if I can find it. We're talking about autoscopy, yes. Autoscopy has been interested in humankind from time immemorial and is abundant folklore, mythology, and spiritual narratives of the most ancient modern society. Okay, so if that's the case, that means that everything that I've been thinking about, imagining through this process they call autoscopy, right? Autoscopy has given the ability to be able to transfer my mind to that time and era where the body can't go. You know what I'm saying? How many of us have done that? How many of us have done that? All right? Because it's very important because you're only here experiencing of what's going on. It says self-watching. You're either watching with your mind or watching with your physical body. And your physical body can only see with your eyes. And your eye is totally contrast to a mental image. A visual image is contrast to a mental image because we know mental images do signals in waves as well, as light does as well. But it's nothing more than signals and waves. Ultraviolet rays, I might add. All right? Because light is ultraviolet radiation. All right? So let's go back to out of body experience, right? Which one perceives the body, perceives the world from a location outside their physical body. All right. This is what you were supposed to be understood at this time and point within the expiration of the 6,000 year time frame given. This is what you're supposed to be knowing. If you and you are given the privilege to know this through the revelation that I'm giving to you, which is the ability for you to transition out of here based off you having a concept through a mental image. All right. A mental image through autoscopy, right? Autoscopy, mental imaging, mental transferring, a mental uploading. All right. when you're meant to uploading, you have to go to a transmission medium. And transmission medium is needed for interstellar travel. All right, which is an interstellar medium. And we know interstellar medium means the space between stars. And we know that's luminous, furious ether. Y'all don't hear me. Let's go back here. Let's go back to it. A human narrative from England is transported out of his body via unexplained means. So I'm transporting back to the narrative and explaining in England, from England's standpoint, of where the whole point of the story originated from in regards to what we call time immemorial. Time immemorial. We know Henry II was son of Godfrey the Fifth Caravan Jew, where I'm descended down from through my surname Jefferson. On the in regards to either cellular lineage or from genealogical or ethnological view. Whatever view you want to look at it, I've covered that. All right. The human narrative from England is transported out of body via unexplained means. He realized he is able to explore space and other planets. After exploring a civilization on another planet in our galaxy at a level of development similar to our own that existed millions of years ago, thousands of light years from Earth, i.e. the other Earths. In some detail, his mind merges with the other inhabitants, and as they travel together, they are joined by still more minds of group minds. So you must have the same mind to be able to make the same mental transition with it through an out-of-body experience. All right? An out-of-body experience, which is denotes what we call that vacuum. That vacuum, as a result of the information receiving through the out-of-body experience, allows the transition to take place. All right? It allows the transition to take place that you can go into your true body, i.e. your etheric body. The climax of the book is the supreme moment of the cosmos when the cosmic mind, which includes the narrator, attains momentary contact with the titular, i.e., the star maker. The star maker is the creator of the universe, but stands in the same relation to it as an artist to his work, and calmly assesses its quality without any feeling for the suffering of its inhabitants. This element makes the novel one of Stapleton's efforts to write an essay in myth-making. After meeting the star maker, the traveler is given a fantastic myth or dream, in which he observes the star maker at work. He discovers that his own cosmos is only one of the vast number, and by no means the most significant. He sees the star maker's early work, and he learns that the star maker was surprised and intensely interested when some of his early toys, i.e. universes, for example, a universe composed entirely of music with no spatial dimension, displayed modes of behavior that were not in accord with the canon which he had ordained for them. He sees the star maker experimenting with more elaborate universes, which includes the traveler's own universe, a triune universe which closely resembles Christian orthodoxy. The three universes respectively being hell, heaven, and reality with presence of a savior. Did you hear that? And a branching universe similar to that of many worlds interpretations of quantum mechanics. The star maker goes on to create mature universe of extraordinary complex and culminating in the ultimate cosmos, through which the star maker fulfills his own internal destiny as the ground and crown of all things. Finally, the traveler returns to Earth at the place and time he left to resume his life there. Did y'all hear that? Did y'all hear that? They actually made a movie about it. Moonfall. Moonfall. All right, everybody look at this movie up. Halle Berry plays in it. It said they reached the interior of the moon, revealed to be a Dyson sphere. All right, powered by a white dwarf at its center. The Dyson sphere AI operating system explains to Brian that billions of years ago, humanity's technology advanced ancestors were eradicated by a rogue AI. They built the moon as an interstellar ark to create and see life on Earth. But the swarm, the malicious AI, discovered the moon and is signaling energy from its power source, destabilizing its orbit. All right, everybody needs to watch that movie because they talk about the Dyson sphere. We know a Dyson sphere is a mega structure. It's a mega structure as a result of the collapse of what we call our planetary nebula. All right. And based off the expansion, when it cools, all the elements that's attracted by the gravitational pull of that white dwarf when maintains in what we said that gravitational pull based off the gravitational singularity as a result of the creation of that expansion of the universe. All right, which we know now is subject to this black hole. All right, which is going to occur with the dying out of this star system, which is surely to come upon us. All right, is surely to come upon us. As you can see, the Dyson sphere, and when it made reference to Star Maker, let's go back there. What is that at? Very important to understand this, what they're trying to tell us. Key point. Okay, right here. After exploring a civilization on another planet in our galaxy at a level of development similar to our own that existed millions of years ago, thousands of light years from Earth, the other Earth, in some detail, his mind merges with that of one of its inhabitants. And as they travel together, they are joined by still more minds or group minds. This snowballing process is paralleled by the expansion of the book scale, describing more and more planets and less in detail. So by the realization through the process of what we call out of body experience, and they said through an out of body experience, through mental or mind transference. So when you're reviewing this lecture that I'm teaching you, I'm giving you the ability to be able to make the transition, not by way of a new physical body, but a mental body, the original body, through an out-of-body experience, through what they call daydream. We call it engrams. All right, a mental perception of yourself. All right, that you can travel like-minded people. You can travel with like-minded people. Out-of-body experience is a phenomenon of which person perceives the world from a location odd to their physical body. An out-of-body experience is a form of autoscopy, literally seeing self, although this term is more commonly used to refer to the pathological condition of seeing second self. And we know autoscopy goes back to what we call time immemorial. What is that? Autoscopy has been interesting to humankind from time immemorial. and is abundant in the folklore mythology and spiritual narratives of most ancient and modern societies. So it's very important to understand that in order for you to make the transition to the shift from three-dimensional to fourth-dimensional, we all must have the same mind. We must travel on the same frequency. All right, on the same frequency. For this, it takes what we call tuning, fine tuning. All right, so let's talk about that for a second. All right, let's go ahead. Let's go ahead. It says here, there remain aspects of observed universe that are not yet adequately explained by the Big Bang models. All right. After its initial expansion, the universe cooled sufficiently to allow the formation of subatomic particles and later atoms. The unequal abundance of matter and antimatter that allows this to occur is an unexplained effect known as baryon asymmetry. Once again, baryon asymmetry. This primordial element, mostly hydrogen with some helium and lithium, later let me say that right, coalesced through gravity, forming earlier stars and galaxies. Astronomers observed the gravitational effects of unknown dark matter surrounding galaxies. Most of the gravitational potential in the universe seems to be in this form, and the Big Bang models and various observations indicate that this excess gravitational potential is not created by baryonic matter, such as normal atoms, i.e., regular matter. Measurement of the redshifts of supernova indicate the expansion of the universe and accelerating in the observation attributed to unexplained phenomenon known as dark energy. We know dark energy is luminous spurious ether. All right? Dark energy is luminous spurious ether. We know that it's just said that most of the gravitational potential in the universe seems to be in this form, and that the Big Bang models of various observations indicate that this excess gravitational potential is not created by baryonic matter. What is baryonic matter? Let's check that out. What does matter? In classical physics and general chemistry, matter is any substance with mass and takes up space by having volume. All everyday objects that can be touched are ultimately composed of atoms, which are made up of interacting subatomic particles, and everyday as well as scientific use. Matter generally includes atoms and anything made up of them and any particle that act as if they have been rest, mass, and volume. All right? That's what matter is. So what is baryon? Baryon matter. Nearly all matter that may be encountered or experienced in everyday life is called baryonic matter, which includes atoms of any sort and provides them with the property of mass. Non-baryonic matter, as implied by the name, is a sort of matter that is not composed primarily of baryons. This might include neutrinos, free electrons, dark matter, supersymmetric particles, axion, and black holes. Did you hear that? The very existence of baryons is also a significant issue in cosmology because it is assumed that the Big Bang produced a state with equal amounts of baryons and antibaryons. You hear that? Baryons matter and antibaryons. Antimatter. The process by which baryons came to outnumber their antiparticles is called baryogenesis. Did you hear that? Baryogenesis. So, in order for you to move from what they call anti-baryon, move to anti-baryons from baryons, you must understand the baryogenesis of matter. And we know matter is mass, and mass occupies space, and space is occupied by distance. All right, because the further you go, the more distance you have, more space you got in between. All right, as we can see in the study of cosmogony. All right, we see that. All right, so we understand that neutrinos, such as electrons, dark matter energy, dark matter is what we call ether, luminiferous ether, supermetric particles, axion, and black holes are not the same as baryonic matter. All right, so in order to make this shift, then you must have what they call baryonic fine tuning. It's called baryonic acoustic oscillation. Baryonic acoustic oscillation. It results in what we call fine tuning ourselves. Fine tuning ourselves. This comes due out of body experience, OBE. All right, daydreaming. In cosmology, baryonic acoustic oscillation are fluctuations in the density of the visible baryonic matter, normal matter of the universe, caused by acoustic density waves in the primordial plasma of the early universe. Y'all better listen to what I'm telling you. Y'all better listen to what I'm telling you. I know what I'm talking about. In cosmology, baryonic acoustic oscillation are fluctuation in the density of the visible baryonic matter, which we call normal matter. You got anti-baryonic matter and baryonic matter. We know baryonic matter is normal matter, which we see, that we're exposed to. All right, versus the antimatter, or what we call baryonic matter, which exists before the universe came into existence. That nothingness, all right, which occupies what we call luminous, spurious ether. It says, baryonic matter, normal matter of the universe caused by acoustic density waves and the primordial plasma of early universe. And the same way that supernovas provide a standard candle for astronomical observation. You hear that? All right, go right back up here. So once again, in cosmology, baryonic acoustic oscillation are fluctuations in the density of the visible baryonic matter, normal matter of the universe caused by acoustic density waves in the primordial plasma of the universe. What is acoustic? Acoustics is a branch of physics that deals with the study of mechanical waves in gases, liquids, and solids, including topics such as vibration, sound, ultrasounds, and infrasound. We know a transmission medium is the ability to transfer signals. All right? The ability to transfer signals. All right? A scientist who works in the field of acoustics is an acoustician, forgive me. While someone working in the field of acoustics, technology may be called an acoustical engineer. Anybody hear that? Etymology of the word acoustic derived from the Greek word meaning of or for hearing, ready to hear, and that from heard audible, which in term derived from the verb I hear. All right. So if you're here, then that means you should be listening to me. All right, because that's the only transmission medium that you're gonna get. Why? Let's go back to transmission medium. Luminous, various, ether. Luminous, various, ether was a postulation medium for the propagation of light. It was invoked to explain the ability of apparently wave-based light to propagate through empty space, i.e. a vacuum. All right. What is the medium? Transmission medium. Sorry. Transmission medium is a system of substance that can mediate the propagation of signals for the purpose of telecommunication. All right? Telecommunication, send signals. Signals are typically imposed on a wave of some kind suitable for the chosen medium. So if you hear this, then you are a chosen medium through that interstellar medium. We know an interstellar medium is ether. You are a chosen medium. For example, data can modulate sound in a transmission medium for sounds may be air, but solid and liquids may also act as a transmission medium as well. Vacuum or air constitute a good transmission medium for electromagnetic waves such as light and radio waves. You hear that? So air, as well as solid liquids, can be a transmission medium. But on an interstellar level, then in order for that medium to exist, for the transmission of those signals must be an interstellar medium, which we'll go back here. Interstellar medium. History and knowledge of interstellar space means that the space between stars. We know stars result from nebula's gravitational pull collapse. All right, i.e., general what is called gravitational singularity, i.e., that's the study of cosmogony, the beginning, the study of the beginning of our universe and everything that exists within our universe. It says the history in regards to the study of the space between the stars, and we know that that space is called space is nothing, which exists within ether. Since the word interstellar between space are coined by Francis Bacon and the concept of ancient theory of little spheres of fixed stars. Later in the 17th century, when the idea that stars were scattered through infinite space became popular, it was debated whether the space was a true vacuum or if it was hypothetical fluid, something called ether. As Rene Descartes' vortex theory of planetary motion, while vortexes theory did not survive the success of Newton's physics, an invisible luminous spheres ether was reintroduced in the early 19th century, okay, to fulfill that understanding of what they were missing in regard to that interpretation. All right, we have to understand this. Let's go back here. Let's go back to the video real quick.
That we are left without answers. We know that something is transpiring in the cosmos, leading to the disappearance of stars from our observations and views. It cannot be dismissed as a random occurrence, as we have detected numerous missing stars. The crucial question remains, what is causing so many stars to vanish within a relatively brief time frame? This is why numerous individuals and organizations from various disciplines are dedicated to unraveling this mystery. Solving these questions could provide us with a deeper understanding of the universe. If similar phenomena occur in the future, we may be better equipped to discern their causes promptly. While the mysteries of star disappearance linger, something new has emerged deep within the cosmos. Scientists have recently discovered immense voids in space that exceed our initial assumptions, extending to a scale encompassing the solar system and the Milky Way. The universe is rife with voids, vast expanses where celestial entities are notably scarce. One such remarkable void is the Bootes.
Hey guys, Toby Mathis here, and question I get all the time is, how do I make my personal assets invisible? Well, first off, can you even do that? And the answer is yes, you absolutely can. I'm going to show you 3 major issues that you need to hit, and then I'm going to invite
Void, or the Great Nothing. When you gaze upon the night sky, it often appears uniform with abundant stars scattered evenly. However, regions like the Bootes void differ significantly as they contain a few celestial entities. In essence, the universe comprises a unique structure, lengthy filaments of dark matter interwoven with galaxies and clusters of galaxies, punctuated by expansive voids. These voids are vast, desolate regions, devoid of matter. To truly fathom the universe, we must peer into these enigmatic abysses. The most extensive known void within the universe is the Bootes void. This vast, empty, spherical expanse in space boasts a diameter
Or Bootes constellation. Bootes void is in Bootes constellation, just like Orion's nebula has a void, which is what we call empty space. All right, the empty space results in what we call a vacuum, where the gravitational pull is so strong that light can't even escape.
of approximately 330 million light-years. It comprises a mere 0.27% of the universe's overall diameter, a staggering 330 million light-years across. Located near the Bootes constellation, this extraordinary void lies roughly 700 million light-years away. Initially, the void harbored only a solitary galaxy, but only a few dozen more have been detected since its discovery. The average separation between these galaxies places them at intervals of approximately 10 million light-years, a distance 4 times greater than between the Andromeda Galaxy and Earth. This stark contrast becomes evident when compared to our local cosmic neighborhood, the Virgo supercluster. This cluster is a smaller expanse about 110 million light-years in diameter, housing over 2,000 galaxies, including our Milky Way. To illustrate the scale of this vast emptiness, astronomer Greg Aldering once remarked that, if the Milky Way had been in the center of the Bootes void, we wouldn't have known there were other galaxies until the 1960s. In comparison, the Milky Way enjoys the company of about 24 neighboring galaxies within a region just 3 million light-years across. Considering the volume of the Bootes void, it should theoretically accommodate around 10,000 galaxies, given the typical distances between galaxies elsewhere in the universe, which are a few million light-years. Astonishingly, only 60 galaxies have been identified within this expansive void, rendering them some of the loneliest galaxies. The Hubble telescope even provided an image of one such galaxy, MCG plus 0102015. This is a spiral galaxy residing within the Bootes void, described by the European Space Agency as the loneliest of galaxies. How this galaxy arrived in such isolation remains a mystery. Within this observation, you can spot 3 foreground stars, all from our Milky Way. All other points of light are distant background galaxies, resembling a swarm of microorganisms in a water droplet. But how do these voids come into existence? Computer simulations have illustrated that smaller, more common voids result from the gravitational attraction of galaxies pulling closer together, leading to the depletion of neighboring regions. However, this explanation cannot apply to the
Gravitational
Proof's void,
singularity.
as there simply hasn't been enough time since the universe's inception for gravitational forces alone to clear out a space of such immense proportions. As such, this brings us to the Big Bang theory. When most people imagine the universe's expansion following the Big Bang, they likely picture an evenly distributed scattering of galaxies receding from one another. However, a more intricate structure emerges when we examine the universe on the grandest scales, such as fitting billions of light years into a computer screen-sized cube. Let's rewind the universe's clock to its early moments shortly after the Big Bang. The universe was a condensed region of intensely hot plasma
Listen,
at that
y'all.
time. Despite its predominantly uniform density, there were minute variations or quantum fluctuations in space-time. As the universe expanded, these minor variations in matter density became increasingly pronounced.
That's this field right here. That's called ether. Luminous spirit ether. The planets swim in it. All right. This is what this is called.
Consequently, regions with higher and lower matter densities emerged on cosmic scales. Fast forward 13.8 billion years from the Big Bang, and we can observe how these tiny deviations at the dawn of time evolved into the colossal
a nebula.
structures we see today. These structures comprise vast walls, each consisting of thousands of galaxies rather than individual galaxies. They are interconnected by nodes where filaments of galaxies converge. These are colossal structures, stretching thousands of galaxies wide and hundreds of millions of light years across. The spaces, or voids, between these galaxy clusters are even more expansive. Specifically, these voids aren't entirely devoid of matter. They are less dense than those filled with galaxies. Their matter density typically amounts to about a tenth of the universe's average density. As a result, these voids still contain dark matter, gas, dust, stars, and galaxies, albeit in smaller numbers. For example, there are 17 distinct galaxy clusters within the giant void alone. As the universe expands, these voids, like the Booty's void, will continue to grow. The walls and filaments connecting galaxy clusters will stretch and rupture, leaving only gravitationally connected clusters of galaxies in the expanding void. As these voids merge, the sheer size of the observable universe is simply astonishing. Meanwhile, our location within this vast cosmos is part of the local group, a component of the Virgo supercluster situated on the edge of a colossal cosmic void. But there is still much to discover in this immense expanse. So far, astronomers have identified the greatest known structure in the cosmos, a massive void known as the supervoid. This supervoid spans a staggering 1.8 billion light-years in diameter and stands out for its extraordinary emptiness. The supervoid offers answers to questions that have intrigued scientists for over a decade while raising new inquiries that hint at the emergence of alien physics. The amount of cosmic matter, including galaxies and dust, within the supervoid is approximately 20% less than in our universe region or any area with a typical density. While it isn't empty, it certainly feels like a vast and chilly wasteland compared to other regions of space. This supervoid's existence ties into the discovery of the cold spot, a region of space noted over a decade ago for its unusual size and lower temperature. This is different from what would have been predicted given its cosmic microwave background, CMB radiation, the thermal radiation remaining from the Big Bang. Scientists have been searching for a void within this area because, as photons travel through an expanding universe, they lose energy and cool when passing through a void. Scientists have known for years that confirming this region's extremely low density would help explain why the cold spot exists. This phenomenon arises from the conversion of photon kinetic energy to gravitational potential energy as photons move away from denser areas of the universe and toward the center of a void. This energy conversion results in a temperature drop, causing light to leave with a longer wavelength and colder temperature. To determine the number of galaxies in a region of space located approximately 3 billion light-years from Earth, Istvan Sapudi from the University of Hawaii took up the challenge with his team. The team included Andras Kovac from Eötvös Loránd University in Budapest. They employed the Pan-STARRS 1 telescope in Hawaii and NASA's Wide Field Survey Explorer satellite. Their findings unveiled that the cold spot exists within a substantial, sparsely populated region. Although the structure might not appear as a standalone entity, it is remarkable considering this scale's typically uniform distribution of the cosmos. Regrettably, only 10% of the temperature difference between the cold spot and adjacent galaxies' average temperatures can be attributed to the supervoid. Back to the Bootes void, it wasn't until the discovery of dark energy in 1998 that an explanation emerged. Dark energy is a cosmic force that induces the expansion of empty spaces as if the entire universe were inflating simultaneously. Many astronomers believe these enigmatic regions, which expose the universe's fundamental structure, could serve as signposts for the subsequent significant discovery. There is a surge in efforts to catalog and map voids, allowing us to quantify dark energy, gravity, and any unforeseen new forces with greater precision through statistical analysis of their shapes. Furthermore, recent evidence suggests that the vast deserts of near-empty space that dominate the universe may accelerate its expansion. This implies that dark energy, the mysterious force believed to be driving the cosmos apart, could be attributed to these vast expanses of emptiness. In essence, the universe is expanding every day and growing larger with each passing second. The phase of accelerated expansion, which appears to have commenced approximately 5 billion years ago, remains a mystery for astronomers. Dark energy was a clever term for this immense cosmological enigma. But what connection does dark energy have with these cosmic voids? One significant reason is that the consequences of accelerated expansion are not observable within star systems or galaxies due to the dominating gravitational pull of matter. Dark energy, for instance, hasn't caused the Milky Way or our solar system to expand. However, since cosmic voids are exceedingly sparse in matter, they are far more susceptible to the influences of dark energy. Therefore, it seems prudent to investigate the nature of this accelerated expansion in the regions where it exerts the most influence. A recent study posits that dark energy is not only present in voids, but may also be a consequence of their existence. This raises the question of how these vast void regions might instigate a quicker universe expansion. Thank you for watching another episode of Voyager.
Okay. So let's review dark energy in closing. All right. In physics, cosmology, and astronomy, dark energy is an unknown form of energy that affects the universe on the largest scale. Its primary effects is to drive the accelerated expansion of the universe, i.e., the Big Bang. You see that? You see that? Y'all see it. That's cosmogony. All right, the study of the universe. This is what we all should know. Let's go to the origin. Einstein's cosmological constant. A cosmological constant is a constant term that can be added to Einstein's field equation of general relativity. If considered as a source term in field equation, it can be viewed as the equivalent to the mass of empty space, which conceptually could be either positive or negative or vacuum energy. When you say vacuum energy, that means absence of matter. i.e., matter as we know it. They're talking about antimatter, all right, i.e., 0 point energy. The cosmological concept was first proposed by Einstein as a mechanism to obtain a solution to the gravitational field equation that would lead to the static universe, effectively using dark energy to balance gravity. All right. The mechanism for an example of fine tuning. It was later realized that Einstein's static universe would not be stable. Local homogeneities, parts of local inhomogeneities will ultimately lead to either the runaway expansion or contract of the universe. All right. So, what is fine tuning? In theoretical physics, fine tuning is the process in which parameters of a model must be adjusted very precisely in order to fit within a certain observation. This has led to the discovery that the fundamental constant in quantities fall into such extraordinary precise range that if it did not, the origin of evolution of conscious ages and the universe would not be permitted. So you must fine tune yourself to what they call variant acoustic, what it said, variant acoustic oscillation, variant acoustic oscillation. All right, let's go back to where we was in closing. As we can see again, Big Bang, a star exploding, and a star exploding results in gravitational collapse. All right, gravitational collapse. We know that when we deal with planetary nebulas, they give birth to stars. All right, they give birth to stars. Let's go to the origin, and then we'll close. Okay. And quintessence. Models of dark energy, the observation acceleration of the scalar factor is caused by the potential energy of the dynamical field referred to as quintessence field. Quintessence differs from the cosmological constant in that it can vary in space and time. In order for it not to clump and form structure like matter, the field must be very light so that it has a large Compton wavelength. In the simplest scenario, the quintessence field has a canonical kinetic term and minimally coupled to gravity and does not feature higher order operations in its Lagrangian. All right. We know quintessence is what they call dark matter or ether. Quintessence is also called dark matter or the fifth element. It's called the fifth element. Bear with me, let me find it. Okay. All right here. Dark energy. The cosmological constant and the constant term that can be added to Einstein's field equation of general relativity is considered as a source term in the field of equation. It can be viewed as equivalent to the mass of empty space. You hear that? The mass of empty space conceptually could be either positive or negative, or vacuum energy. What is vacuum energy? Vacuum energy is the underlying background energy that exists in space throughout the entire universe. The vacuum energy is a special case of zero-point energy that relates to quantum vacuum. All right? Quantum vacuum. Let me go here to zero-point energy once again. It says here, all these fields have zero-point energy. These fluctuating zero-point fields lead to a kind of reintroduction of an ether in physics. All right, since some systems can detect the existence of this energy. All right, and that leads me to close with ether as a classical element. According to ancient medieval science, alternatively spelling includes aether, and ether, also known as the fifth element of quintessence. Void or nothing is the material that fills the region of the universe beyond the terrestrial sphere. The concept of ether was used in several theories to explain several natural phenomena, such as the propagation of light and gravity. In the late 19th century, physics postulated that ether permeated space, providing a medium through which light could travel in a vacuum. But evidence for the presence of such medium was not found in Michelson-Morley's experiment, and this result has been interpreted to mean that no luminous sphere ether exists. That's a lie. That is a lie, because we know that according to mythological, and we know mythological study of cosmogony, or the study of our universe, started from ether. All right. The word means pure fresh air or clear sky, and it was thought to be the pure essence that God breathed, filling the space where they live, analogous or contrast to the air breathed by mortals on this terrestrial sphere. All right. Is related to means to incinerate, to intransitive, to burn, or to shine, meaning people with a burnt black facade. All right. People with a burnt black facade. So if you fit that description, then I suggest that you get back to the understanding of who you truly are. All right? Please come to the realization of who you truly are. All right? So with that, I'll close my share. And I hope that everything that I said will be able to be digested. Like I said, I'm not a scholar, but I make sense of what's given to me based off the ability for me to interpret what was given to me as described within the 6,000-year time frame. All right, so without further ado, I'll close and I greet you in the name of my ancestors. Peace.